video I look at adopting a more theoretically sound approach. Approach to ordered hashing. Now at the outset I must distinguish between hashing for the sake of database access, ordered hashing for the sake of database access, and ordered hashing for the sake of data compression. They are both related. First I look at ordered hashing. In this video I only look at how to define database access functions for a string of digits in terms of an ordered database access function for a single digit. Similarly, how to define a data compression hash function for a string of digits in terms of an ordered compression hash function for a single digit. So this is the approach I should look at in this part. Another general more approach will be in another video. So first, for the database access, we wish to hash a number m which lies between m to a number where the length of m is much larger than the length of s in terms of bits. If m is 2 power l dash and s is 2 power l, we wish to perform this mapping where l dash is much larger than l. So this is the basic definition which we have. There are two ways for database access. There are two obvious ways for defining a hash function. One is the product approach, where we define h of k as equal to s minus 1 times f of k. The other is the power approach, where we define h of k as s power f of k minus 1. Now there are two conditions that f of k must satisfy. They are the following. Number 1, for all k 0 less than equal to f of k less than equal to 1 must be true. And the second one, for any two k's k1 comma k2, k1 less than k2 implies f of k1 less than or equal to f of k2. Now since the length of the key k is very large, k is less than m, we have to define a hash function for f of k in terms of its digits. First I shall only consider the binary case. We can always define f of 2k is equal to f of k plus 1 by 2. Alright? So this means f of 2 times k plus 1 will be equal to f of k plus 1 plus 1 by 2. That means f of 2k plus 1 will be equal to f of k 2k plus f of 2 times k plus 1 by 2 is equal to f of k plus, f of k, this will come up to f of k plus f of k plus 1 plus 2 by 4. We could, since we know the ratio s by m, we could define f of k plus 1 simply as equal to f of k plus something like s by m or something like log s by log m or some such ratio which is reasonable for a given particular distribution of keys. So we can define this inductively as follows. The same thing can be generalized to any arbitrary base. That is, we can always define for any arbitrary base B we can define f of k is equal to f of b times k will be equal to f of k plus b minus 1 by b. Likewise, we can define f of b times k plus 1 will be equal to f of k plus 1 plus b minus 1 by b. Therefore, for any larger k, f of b times k plus b will be equal to d times f of k plus f of k plus 1 plus 2 times b minus 1 whole divided by b square. Again, f of k plus 1 can be defined in a like manner as it was for earlier. So this can be generalized, so we can define f of k for a string of digits in terms of defining f of k in terms of digit of a single digit, meaning the entire hash function for database access for a string of digits, ordered hash function for a string of digits of the key can be defined in terms of an ordered hash function for a single digit. Likewise, for the case of database access, this is just as we have defined. We can also define a hash function for the ordered compression hash function. So the ordered compression hash function for a string of digits can be defined in terms of an ordered compression hash function for a single digit as follows. So we have the number is constructed as digits d0, d1, d2 and so on up to di. This is the entire number. So what we can define h of n will be equal to h of di and so on up to d0. We can define this as being equal to h of di times h of b minus 1 whole power I plus 1 plus h of di minus 1 d0. That is, this number is nothing but the leading digits removed. So we take the di into h of d minus 1. This is hash function for a single digit. And here we assume h of d minus 1 whole power I plus 1 plus h of di. So this is the theoretical way. So we can, even for data compression also, we can define hash function for data compression for a large number in terms of a hash function for data compression for a single digit of that number taken in a particular base B. So this can be defined recursively or inductively in this form. So inductive reasoning is much more powerful. So adopting a theoretically sound approach is certainly better than adopting it will be slightly harder than the practical approach, but it is certainly also a lot better than the practical approach. Now I should look at the second part, I should look at other ways of defining f of k for database access.